Okay, so we're going to take a few examples and take a look at those. To start, we'll look at 2 over root 10. Now, we have a radical in the denominator, so that means we're going to have to rationalize. Meaning, in class, what we did was we took a form of 1, so something from our bag of tricks, and that's a form of 1. So we can do that. We can multiply by a form of 1 without losing the integrity of the problem. So on the top, we just get 2 root 10. And on the bottom, we get root 10 times root 10. And we can say it's root 100, but we should also start to see mentally that that is just going to give us 10. So that's all we do as far as the basic process of getting the denominator rationalized. Now we don't have a radical. That was our goal. The goal was not to have a radical. No radical in the denominators. Next problem, we got root on the numerator and denominator, but we're only concerned about rationalizing the denominator. Root 3 over root 3 using a form of 1. We get root 21 and over root 9, where we should start to see mentally, we got root 21 over 3. We want to inspect this to see if we can simplify it anymore. Can't think of any perfect squares that break down 21, so we happen to be in our simplest form. So now we bump it up to the third problem. Now I've got 2 terms in the denominator, and this could be problematic, but we can also use this idea of conjugates. Now remember, conjugate looks pretty much the same, but it's 3 minus root 7, and we want to do the same to the top because the idea is we want to multiply by a form of 1. So a form of 1, meaning when we divide this, that's really multiplying it by 1. Now if we take this, and we can see that we're going to have a distributed property occurring on the numerator. So we got to distribute that 3. So 9 minus 3 root 7 all over. Now we've got, as most of you know, FOIL has got 2 terms times 2 terms. And I'm going to write it out just to illustrate again what happens in the middle terms here. So I got 3 times 3 is 9. Got minus 3 root 7 plus 3 root 7. And then I have minus root 49. Nice denominator, real straight. Notice that we are going to have this occur in our problem, which is nice because we know that's going to go to 0. So we really got 9 plus 0 minus, well, we know that's going to be 7. So 9 minus 3 root 7 on top over 9 minus 7. Almost done. Simple subtraction yields 9 over 3 root 7 over 2. And that's our final answer. Nothing we can do on the top because this 9 here is really 9 root 1. And they're not like radicals, so we cannot combine them. Just thinking about like terms in algebra, it's the same idea. And there we are with a few problems to illustrate rationalizing denominators.